Hello everyone, I'm Jerry. Below is a comparison between waterjet cutting and laser cutting, based on factors like material type, thickness, bucket, and cutting quality requirements. Working principles. Waterjet cutting. It uses an ultra-high pressure water pump, typically operating at 60,000 psi, or approximately 100 bar, to accelerate water into an extremely thin, high-speed jet with a diameter of about 1 to 1 毫米. Abrasives such as garnet sand are usually mixed into the water. The material is cut through the grinding action of these abrasives. A pure water jet can cut soft materials like foam and food, while a water jet with added abrasives can cut almost any hard material. In essence, it is a grinding cutting method and falls under the category of cold cutting. Laser cutting. It uses a high-power density laser beam to irradiate the warp-piece. The irradiated material quickly melts, vaporizes, or reaches its ignition point. At the same time, a high-speed gas flow coaxial with the laser beam blows away the molten material to achieve cutting. In essence, it is a thermal cutting method. Core comparison dimensions. Applicable materials. Waterjet cutting. Its applicability is extremely wide. It can cut almost any material, including metals, steel, aluminum, titanium, stone, glass, ceramics, composite materials, plastics, rubber, and food, with no selectivity. Laser cutting. Its applicability is selective. It is mainly good at cutting metals, carbon steel, domestic, aluminum, copper, ejector, and can also cut many non-metals, acrylic, wood, plastics, percussion. However, it has poor cutting results or poses risks for reflective materials such as gold, silver, copper, some composite materials, and flammable materials. PVC releases chlorine gas. Laser cutting also struggles with highly reflective and transparent materials. Cutting thickness. Waterjet cutting. It can handle very thick materials, easily cutting through heavy materials over 150 mm thick, even up to 300 mm. Its cutting capacity is almost only limited by equipment power and abrasive supply. Laser cutting. Its cutting thickness is limited and depends on laser power. A 10,000 watt fiber laser can cut carbon steel 50 to 100 mm thick, but beyond that thickness, the cutting speed becomes very slow and the cross-section quality declines. It is better suited for high-speed, high-quality cutting of medium and thin plates. Waterjet cutting is the first choice for ultra-thick materials. Cutting quality. Waterjet cutting. TED has no heat-affected zone, so it will not change the material's properties. However, the cross-section usually has a slight taper, and the surface has a frosted texture caused by abrasives. Its precision is very high, reaching 0.1 毫米. Laser cutting. The cut is smooth and vertical, with extremely high precision, plus or minus 0.5 mm, and can even achieve a mirror finish. However, it has a heat-affected zone, which may change the malolographic structure of the material's edge. This is a drawback for some precision applications. Laser cutting is usually superior in terms of finish and precision for thin plates, while waterjet cutting is cold and has no thermal effects. Cutting speed. Waterjet cutting. It is slow, especially when cutting complex shapes and thick materials. Its speed is greatly affected by the material's hardness and thickness. Laser cutting. It is very fast. When cutting medium and thin plates, its speed is several times, even dozens of times faster than that of waterjet cutting, with extremely high efficiency. Laser cutting has a huge advantage in efficiency and is the first choice for mass production. Operating cost. Waterjet cutting. The operating cost is relatively high. The main consumables include elections, abrasives, water, unwearing parts, nozzles, mixing tubes. Abrasives are continuous bulk consumables. Laser cutting, the operating cost is moderate. The main consumables include electricity, auxiliary gases, nitrogen, oxygen, air, and lenses. Protective lenses, focusing lenses. Fiber lasers have high electro-optical conversion efficiency, which has significantly reduced energy consumption. Perceives. Environmental impact. Waterjet cutting. It produces high noise and requires treatment of waste and waste residue. Laser cutting. It produces low noise but large amounts of smoke and dust, requiring an efficient exhaust system. 对, how to choose? Choose waterjet cutting when 1. You work with diverse and complex materials. You need to cut workpieces made of various materials, such as metals, stone, glass, and composite materials. 2. You need to cut ultra-thick materials. You frequently cut metal or non-metal materials over 50 mm thick, especially those over 100 mm thick. 3. Thermal impact must be avoided. The materials you process or the final products cannot tolerate thermal effects at all. This prevents material deformation, cracking, reduced hardness, or internal stress. 4. Your budget is limited. You are sensitive to the initial equipment investment and mainly process thick plates or complex materials. Choose laser cutting when 1. You mainly cut thin metal plates. The core of your business is processing medium and thin metal workpieces. 2. You pursue efficiency and output. You need high-speed mass production and have strict requirements for production capacity and delivery time. 3. You require extremely high cutting quality. You need smooth and precise cuts to reduce secondary processing, with high appearance requirements. 4. You need high automation. You want to seamlessly integrate with automatic loading and unloading systems. 4. Summary and trends. Waterjet cutting is a versatile cold cutting tool. With its unique advantages of material versatility and no thermal effects, it is irreplaceable in specific fields. Laser cutting is a high-efficiency leader in thermal cutting. In the field of medium and thin metal plates, it excels at. It holds a dominant position in terms of speed, precision, and automation. Trends. Nowadays, many large manufacturing enterprises are equipped with both types of equipment, arranging production flexibly according to order requirements. Even high-grade technologies like water-guided laser cutting have emerged, combining the advantages of both methods. For processing plants, the best choice depends on their core business and the materials they mainly handle.